So, good morning, everyone. Welcome to our fourth online session on the development of a quality scheme for heat flow data in general and for the global heat flow database of the International Heat Flow Commission in particular. Good morning, good day, good evening. I think it's more precisely. Glad to see you here. Today, we start to talk about the temperature-related issues, but beforehand, I will start with a presentation and give a short overview about what happened so far, about the current state of the proposed scheme, and then I think we can quickly start with discussions. Are there some initial questions from one of the attendees first we should clarify? Or can we just start from the head? Which is apparently not the case. So start here. So you should see my screen and the presentation. Is that right?
Yes.
Yes, thanks for the feedback. So, where is this? Okay, so the agenda is quite similar to the previous one. So, first of all, we need someone who's writing a protocol again, which I will write something, but I cannot write the main parts. So would someone volunteer to write notes for the protocol?
I guess once again, I will do it. If no one else wants, I'm willing.
Okay, perfect. Then.
I'm sorry, but I'm not good at all to do these things. I am completely okay. I prefer not do it.
Okay. In any case, anyone can of course share his own notes and contribute to the protocol with that. But Ben will do this now in responsibility. Perfect. Yeah, there are no news today, but I will start with, to give a wrap up on what we have discussed so far in the past 3 workshops. And I will keep it short because most of you had been in most of the workshops, or at least 2. So the basic idea of the quality scheme proposal so far is to have a kind of combined quality score that includes a scoring of uncertainty, of the methods used, and of the perturbation effects, all in one combined score that is visible on the first view. We went through those different aspects, but the main advantage here is that we consider numerical uncertainties as well as a kind of methodological quality, and we include also the perturbation effects that we have discussed last time and the time before last time as highly relevant. And with this kind of score, it simply allows us to have a quick comparison in the first evaluation of different heat flow values at different locations. Just flipping through the slides here, we quickly talked about uncertainty quantification, but this part is something we need to have a deeper look on it, not today, probably during the workshop, because I think the questions how to determine uncertainties here could be a matter of debate to find a suitable way to do this. So I just flip through this part here. The perturbation effects, just to get this to remember on this, are the the letters and cases behind or at the very end. It's the third part, so we can reflect whether an effect is present but not corrected for, or it is corrected, or it is not present or recognized at all. So that are the XRT case letters to the right here. And then as third part, we discussed a bit more into details the methodological quality. So the basic idea was, okay, to have some the dimension of the temperature gradient and the dimension of the thermal conductivity, and there must be a kind of rating which give ratings values in both dimensions, and then one can come up with a kind of matrix to determine how to classify probably those matrix values into a scheme of probably 4 classes or similar, which then reflects somehow the quality. So that was the basic idea. And during the last workshop, we discussed the conductivity dimension here and suggested and discussed 2 steps. And the first step then was that, well, the basic idea was that one starts with some start values of 1 and goes through some questions. So question whether the interval depth is reported, how is it selected, and whether within that interval lambda was determined. And then one achieves a reduction of those starting values, or in this case, no reduction at all. And goes from step 1 to step 2, focusing on the dimensions of the saturation of or saturation state of conductivity, the pressure temperature state of conductivity, and probably the source state. So we just discussed a bit about those scoring values here, about the type of columns used here, and the details on that. And so one could think about whether one should extend this a bit, but basically combining the scores from both steps then would result in a conductivity value or in a conductivity scoring value that describes the conductivity dimension in a bit more detail. So this is what we have done the last time, taking care about this, and now we should what we plan to look on the issue of the temperature. And this is probably what we think or we need to think about today. Already last time and the time before, we discussed the question of representativeness. So about the question of number of values in terms of variability or homogeneity or inhomogeneity of the interval. So I think this is a big thing we need to talk about today. How we address this issue on the one hand side. On the other hand side, there's this what I here call step 2. So which quality aspects of temperature we want to include. In our first proposal, we had a classification from probably continuous temperature profiles down to single point measurements. That was a very rough classification in 4 steps. We could think how to refine the scale, for example, whether this is required. There was, for example, the suggestion to add a parameter for the speed of logging, or for the number of temperature data points at all. So that are the 2 aspects actually I would like to talk with you today, and where we need to come to a solution, or let's see, into an agreement or a discussion or whatever. And I think that talking about the step 2 is a bit more straightforward and probably easier to solve, because that are only technical aspects. Talking about the step 1 is probably the more challenging one to come to a solution. So, and at this point, I would like to open the discussion, whether we want to start with the more easy part for step 2, get this finished, and then addressing the questions of variability in homogeneity, or the other way around. So what is your opinion on that?
Sorry, to break the ice. I would like to address a question to the group about temperature. Maybe with this we can start to discuss. My question is about the probe, the instruments for measuring. We were quite active in the 80s and 90s in Spain for data acquisition, but since then, because the group is more or less was a bit split apart, and the funds for geothermal projects were difficult to get, so we stopped measuring, and now we want to start again to measure heat flow in the Iberian Peninsula. The one we get from the 80s was made home, so it is a resistivity. Is the thermal resistivity? So no, thermal resistance of platinum thermal resistance, and it was quite. It is quite precise, but it's very slow, the stabilization and everything. So my question is, what has been the development of thermal instruments for thermometry since then? If you have reference, and you know, if we can acquire confident instrument now, and where? This is my question. Or what you are using for measure temperatures?
Hi, it's Rob here. I'm not sure that I picked up the question that well, but is it the differences between measuring temperatures using standard techniques and using distributed temperature measurement systems that you're talking about, Ignacio?
No, actually, I'm talking about the probes itself, the instrument. You know, because so the one we have now is very old and it's made home. So we want to know what is in the market, but for heat flow measurements, because the normal probes that you can find in logging instruments are not precise enough. So we want to have a millikelvins precision, and I don't know if what are you using for measuring temperatures? What kind of probe, or where we can buy one?
Ignacio, since it's a bit off topic in terms of the workshop, I would suggest that I can share what we use for probes, for specific probes afterwards, and write you an email. Would that be okay? And I would suggest that anyone else who is actively using temperature logging equipment can do the same. But with the experience that usually in the end we are running out of time, I would keep the focus here on the questions for the workshop. Is that okay?
Okay, it's perfect. So you have, I think you all have my email. If you can write an email, because also it's important, not the precision of the instruments, and especially when wells are not deep enough.
Yeah, we would be happy to share what we use for equipment with you. So, okay.
I guess it raises an important issue which you might want to discuss later on in terms of relevance to the interval, Sven. And that is that if you are using a distributed temperature system, then how do you account for that in your ranking or your quantification in terms of, or qualification in terms of the measurements?
Do I understand you correctly that you mean that his question raises an important point? I agree if you talk that he that the questions of this the probing instrument is important, but my impression was that Ignacio was asking for general organizational issues of his own department. So, and that is what I wanted to put into some side stream, not into the focus of the discussion here.
I understood. I guess
yes.
I was just raising the issue in terms of using distributed temperature sensors.
It's for me only to take advantage of this group of experts. So we are a bit oxidated about this data acquisition, and we want to recover. So okay.
Okay, perfect. So that brings us back to the question whether we want to talk about the technical aspects of the temperature-related data recorded, or about the variability and homogeneity aspect, or the questions of representativeness first. Are there any preferences?
So again, using the same topic. Look, our instrument is very old, but imagine it takes a long time to stabilize. So usually we use not a continuous recording. I don't know if now it's possible with enough precision, but we use to take a temperature every 10 meters or every 20 meters, because if not, the process is too long. It takes like 5 minutes or 4 minutes to stabilize. So in our question, in our case, the recording is every 10 or 20 meters for technical issues. I don't know if this is so we cannot record a continuous log. I don't know if this is possible now. If this is possible, this question is not relevant anymore, no? Sven?
Well, I think generally it is relevant, because we have measurements from different instruments over a long period of time. So measurements that had been invented probably in the 50s or 60s.
Okay, okay.
Those we have today.
So you are talking also about the measurements already recorded. Yeah.
Yes, of course.
VHT and everything. No? Yeah.
Exactly. In our initial approach, the instruments itself, so what particular instrument had been used, for example, to record a single VHT, had not been in the focus, because I think similar to the conductivity scheme that mess everything up, it becomes far too complex if we want to go really into the specifications of or the technical specifications of the recording systems or so on. So and that would be also out of the line of previous attempts to to look on such quality schemes. So
this measurement is the worst measurement in our database. It's more, you know, this is a excellent quality, this is a poor quality, and so forth. And so I don't think you need a extremely precise scale for each individual component. That's my view.
Okay. Are there any other views on that?
I agree with Jeff, we just have several buckets for our quality characterization. In the other case, we would have 10,000 measurements and 10,000 quality indications. So this is not a good idea.
Yeah, look, I concur. I think that something like 4 or 5 is probably your ideal, and the 4 that you've got there are a sensible approach. Once you start adding more, it just adds a lot more complication to the process, and it would be nice to balance it with the number of scores that you're likely to get with conductivity as well.
Okay, so
may I ask something about this?
sure.
I mean, those scores from 0.5 to 1.0 on the right-hand side of this screen about why is the single point temperature measurement only 0.5? It can be also a good quality if it is measured, let's say, with the platinum 100 or 1000 probe, or multiple single point temperature measurements also.
Yes, the basic assumption here is that such BHT data or single point DST data or so are recorded in boreholes, and probably I should have mentioned this earlier. Of course, this methodological part we are discussing here really focus on borehole mine data, not on oceanic data, or let's say oceanic heat flow probe data. So the assumption here is that the BHTs usually are recorded during the drilling process, and in many cases are not corrected for this drilling process, and thus have some large inherent errors. And even if those values are corrected, there are a lot of research papers showing that there are some larger remaining residuals even after the correction procedure. So for that reason, it is evaluated with this idea in back of my mind as a lower quality, but those rating values are purely taken out of the air. Okay, so this is something. Yeah. This is something we can openly discuss. This is just a proposal. So if you have suggestions how to come to a more consistent solution here.
Yeah, Sven, one question about this. It's true that BHT is not very confident to but at the same time, usually are measurements that are very are taken very deep. So the relative error usually is less than the shallow value. So at the same time, it's true that the error is big, but the relative error can be less than in shallow measurements. For example, again about the multiple points. Working with a platinum sensor, as has been said before, the measurements are, even if they are discontinuous, can be very, very reliable compared to another continuous probe that are usually in the market. The normal ones in multi-probes usually are of only 0.5 or 0.1 degrees precision. So that's mean our probe cannot take a continuous record, but is much more precise than the one that my colleagues from hydrology are using with the temperature sensor that are not precise enough, especially for boreholes of less than 200 meters depth. So
yeah, yeah, I understand your point. So I think that is why Imokukun raised 2 workshops ago that we should include the aspect of measurement time after drilling, for example. Because I agree, if you have a bottom or a kind of bottom hole or single point measurement a long time after the drilling finished and the perturbations are gone, then technically you derive an accurate measurement probably of the then in situ temperature. So for that, this kind of classification does not consider this point. We can refine this, so we need a proposal for that. Ben.
Just one thought, because we are not only discussing the quality of the temperature data or temperature gradient. I think in the scoring, we must take into account that we want to discuss the quality of heat flow. So if we have a temperature gradient based on only one single measurement, it should have a lower ranking value overall. So maybe this is something we have to keep in mind in this table if we talk about a single point temperature measurement. So how good is the temperature data to characterize a heat flow interval?
Look, it's Rob here again. Look, that's a good point, Ben. I was also thinking about the differences in terms of accuracy of temperature when you say compare a DST or even a static gauge measurement. Now, I think if we've got static gauges in the well, then we're reasonably confident we've got a much more accurate temperature measurement than, say, for a single BHC. So is there any justification for looking at more accurate determinations of your temperature using that type of instrumentation?
First of all, Sandra, good morning or good evening here as well. Rob, I did not know. I don't know whether I got the question right. So because I had some connectivity problems, can you ask us again, please?
I was agreeing with Ben in terms of the difficulties in just having a single point.
Yeah.
But just expanding on that slightly, when we're comparing a corrected BHT with a static gauge measurement, then you're going to have a significant difference in accuracy. And just questioning whether, in fact, there's a justification for accounting for that level of accuracy in terms of these measurements for the grading system.
So would that turn out to refine this classification a bit as a solution?
I'm not sure. I'm not sure of the solution. It may be that you would have an additional grade between the 1 and the 2, where you're using more accurate temperature data, but the issue is that you've still got to deal with the fact that multiple data points are going to give you a better indication of your gradient than just using a single point in the surface temperature. So it's starting to get a little more complicated, but I was just raising the question as to whether anyone sees the value in terms of accounting for the greater accuracy that you're going to get from presumably a DST or a static gauge measurement, as opposed to a single BHT or a corrected BHT measurement.
Okay. Are there other ideas or opinions on that?
Sven, this single point is quite common or not? That is so common that need a special case, special, yeah, or can be introduced or can be merged with multiple. Because I don't know if this is very common, no? To have one. Usually you have 2 or 3, 4 in BHT profiles or BHT logins.
Personally, I know many well cases where you just have 1 point value. I think this is, you know, in Northern Germany, we are talking about 100,000s of wells. So yes, it's common that you have just one temperature value, but it's also common that you have multiple or even temperature logs. So it just appears because simply due to the mass of wells available. So I think it's not a rare situation that you have just a single point measurements here.
Yeah, I can quantify that. In our vendor database, we have over 75,000 single point bottom hole temperature measurements.
That's quite a number. Okay, what I think is that what is not considered here is that are 2 aspects. First, the first aspect is somehow the time after the drilling finished, because obviously you can have a BHT or single point measurements as say the roughest resolution you can imagine, which was measured either closely after finishing the drilling or a long time. So this makes a huge difference. So this somehow needs to be included here. The question is whether those rough one-dimensional classifications should be extended to a kind of matrix, like we have done it for the conductivity, and whether we want to include those time frames as well, to have kind of a bit more matrix style evaluation here, whether this makes sense or not, because the information about the shut-in times are included in the database, so we could use it, at least from they are included as a database item. So one could add this when available as additional information. I know then we quickly run to the point that a shut-in time in a shallow well is not the same as a shut-in time in a deep well, obviously. So that would one need to connect somehow, but yeah, this is now a bargain, how to keep things easy and how to be a bit more closer on reality. I don't know what your ideas are on that.
This is Jeff again. I guess in my mind, the question would be, is a highly accurate single point temperature measurement going to used with surface temperature going to give you a better estimate of the gradient than the methods listed in 2, 3, and 4? My inkling would be no, but I certainly would welcome other comments.
An idea could be, I don't know, what do you think, is if we can like ranking the technique and the instrument. So give a ranking to the instrument itself. If it's a PT 100 or something, so could be the maximum value, and if it's a normal probe with low precision, the lower one with the B together with the BHT. I don't know. And also, as you said, Sven, I agree that the perturbation in the well, for either because it's drill yesterday, the drilling time was very close, or because, I don't know, water circulation before measurements, because it's a groundwater well. So must be also considered.
Yeah, in this term, I disagree, because we're just talking about the methods. The perturbation of the measurements is reflected in the perturbation part of the scoring. So there we have the aspect of flow, for example, included.
It's true. It's true. So yeah. So the drilling time can be also included there, no?
Well, the drilling time is something which is not recorded yet in the database, but the shut-in time is recorded for both endpoints of the temperature gradient measurements. So you might recall that we record in the database, we have fields for the temperature gradient, for a recorded temperature gradient and a computed one, which could be a corrected one. And then we have fields that record what technique or what type of measurement was used for the upper end of the interval determined and for the lower end. And so technically you could create a temperature gradient from different types of measurement devices or techniques. And I think the basic idea was that we describe both endpoints with a shut-in time if available, and that we can use those shut-in times as a kind of quality indicator, but or which helps to evaluate whether the single point measurements like a BHT is of usually poor quality, or we have the rare situation that it was recorded a long time after the perturbation effects are dispersed. But yeah, that's the question whether we just we could add theoretically some columns. For example, we have here the temperature profile in equilibrium, and then let's say an uncorrected situation. And it's a bit inconsistent because here we have PHTs only in uncorrected situations. So of course we could refine it and assume that we have also single point temperature measurements that are probably numerically corrected or are measured after a long perturbation, after a long shut-in time. And then we assume that the scoring, of course, of those single point measurements is much higher than the 0.5. So, and in this term, you would add 2 further columns here for this one, but corrected after long shut-in, and for the multi single point temperature measurements also with a corrected or long shut-in time. So we would have 6 instead of 4 columns, for example, but would keep it relatively simple, because really considering a shut-in time and to define thresholds of good or bad shut-in times then makes things difficult. It would require the depth of the measurement points and actually also the duration of the drilling, well, the time of drilling which we do not have recorded. So probably having a more an easier descriptive classification like this one, but a bit more extended with 2 further columns could be more useful in the very end in terms of the applicability to the type of data we have. But it's just a feeling.
Just a question about this quality of BHT and DST. I mean, drill stem test is usually of better quality than BHT because it is measured inside a certain packer put in the borehole in a well. Do you agree?
It's a matter of time, isn't it? So usually I agree, you have the drill stem test, you have within a packer, and if you have longer flow rates, then you probably have a temperature value that more or less reflects formation temperatures.
Yes, it's closer to formation temperature than BHT, usually.
But if you do this after 6 months or 1 year of extensive drilling, then I don't think that very short pumping rates or pumping times are sufficient to. You know, it's a kind of bargain between drilling time, perturbation times, pumping times, and this. So this is how to evaluate this. I think you're right that obviously drill stem test is under some circumstances gives you a more reliable value, but on the other hand, if you have an open borehole for 5 years and then go up with an absolute temperature measurement having BHT there, you have no perturbations at all as well, right? So this is something where we need to discriminate between.
Another question about continuous temperature profile, number 3 and 4. What is DTS?
Oh, this is distributed temperature sensing. So using optical fibers.
All right. Yes. What about just such a sense of okay, for continuous temperature profile, it can be used also. I would say semiconductor sensor or something, which is also good. I mean, of 1,000 degree resolution, and I don't know, maybe thermistors are also with the same quality.
Yeah. Thermistor, this is meant with Borehole log in these terms. Because you have the thermistor then and you're logging step by step, right?
Yeah, with thermistor, we usually do like step by step, yes.
Yeah, this is what I understood under continuous temperature profile.
Okay, yeah. Then not all. I mean, this table does not show all the possible probes. I mean, which can be used for temperature measurements.
Okay, which one is missing from your point of view?
Sorry?
Which one is missing from your point of view? Can you add to the chat or?
No, well.
Because in some terms, I think Massimo raised his hands, so.
Okay, can you hear me?
Yes.
Okay, thanks. So I was in trouble with the acronym DST because I was thinking about drill stem test. You know that there is another technique that allows to estimate the bottom hole temperature with a higher accuracy, differently from the classical bottom hole temperature measurements. So drill stem test is considered perhaps the most precise temperature measurements of the true temperature, of the formation temperature. And understood. I just understand that. I just understood. Sorry, that it was not included in this table that you prepared. So my suggestion would be that since the accuracy of drill stem test temperature is better than bottom hole temperature, to include it perhaps in the second column. I don't know. This is one suggestion, but there is a conflict with the other acronym that you use. DST means two different things.
Oh, Maximo,
Yeah.
how is this DST measurement?
Oh, it's a specific test that is performed in oil exploration. After drilling is completed, the borehole is first put under pressure, and then pressure is released, and the oil or gas flows up to the surface in a very, very short time, and the temperature is measured. Since this experiment, this test is performed in a very short time, the temperature that is measured is believed the true temperature of a formation. And this is much better than measuring the temperature sometime after drilling. So you have a more precise evaluation of the temperature.
So if I understood, is like measuring the inside fluids.
That's right. And it is assumed that the fluid has the same temperature of a formation where it was contained.
Okay. I'm sorry. Another question about these techniques. Has one experience with DTS with optic fiber? And in this case, what is the precision of these measurements or accuracy?
You mean in Dresden test or in optic fiber?
An optic fiber.
I'm not an expert. I think that Lazzi had experience with optic fiber measurements.
And has anyone experience with optic fibers?
We have one here in Melbourne, and I have personally used it once, but we had lots of difficulties with it. So I wouldn't want to say what the precision or accuracy was. It certainly has fantastic potential. We couldn't get it to work as well as it perhaps should be in the one time that we have tried it so far.
But our group has used it in the past. And if I recall, I haven't been included, but if I recall correctly, then the resolution, not the resolution, the accuracy of the determination was better than 0.1 degrees C. So it's 2 orders of magnitude less than the high precision temperature logs, but even 0.1 degrees C with a larger interval is quite good. So in these terms, yeah, this is and continuous profile here means, you know, the resolution of the DTS probably is 0.5 meter or so, or even a bit less, probably a meter. It depends a bit on the cable you use. But obviously, with a thermistor used for continuous logging, depending on your sampling rate and depending on the speed of logging, you can have a much larger resolution in the centimeter area, for example. But nevertheless, with those distributed temperature sensing cables, you can log the whole profile at once, and then you have a resolution of probably 0.5 meter or a bit coarse. So this was roughly classified as both are techniques for continuous temperature profile logging. And I think usually we are measuring heat flow not in a centimeter interval, so more often in decades of meters, I think. So this difference in resolution does not account too much. Yeah. I think the more important point here is that we can either measure those logs or those continuous profiles in a situation where you have a thermal equilibrium in terms of borehole perturbations due to drilling, or in a situation where you do not have those equilibrium because you are in the perturbed time frame after the drilling, yeah, which makes here a difference. And then so I would make the following proposal. I don't know whether this includes, hopefully it includes most of the ideas and discussion points here. We can split up the first category and we just consider here single BHT measurements in the first category that are perturbed, because I think this is or even unknown in the situation, and we add a second column which is BHT single corrected. Then we have a third column which is also single measurements, and we refer to formation or Driscoll tests, assuming that there is an inherent quality difference between a BHT measurement and a Driscoll test. And then we could also use a fourth category, which is here probably marked as category 2, that we have multiple single point BHT measurements. I don't know whether it occurs that we have several Driscoll tests in a heat flow interval, probably the theoretical situation, I don't know. But probably could refine this in this term that we differentiate between perturbed PHTs and unperturbed, or perturbed PHTs because they are in most cases perturbed, and corrected ones, and separate those from the DRISTEM tests. That would more or less add, I think, 4 additional columns here, and would allow a bit more to order things and refine things. But that does not add additional complexity to the algorithm. But I see a lot of question marks. Ben, what are your concerns?
Well, yes, I'm just thinking if this is helping us really. So to have, I think it's nice but this is what we should make possible for the database itself, to select data where drill steam test temperature data is recorded. So, but when I think of in terms of quality of the heat flow, then I come back to the point that we want to characterize an interval. And so the question is, okay, how good is to have, how relevant it is to have one very precise determined value, and what and how much is it better to have a continuous recording over an interval, which allows to control the changes of thermal conductivity maybe, or some, yeah, so it gets much more information. So I was just wondering if we really need 4 additional columns for the overall ranking of our heat flow. So, yeah, but perhaps it's better to just write it down once again and to discuss this. And I think we will come to the point, nevertheless, maybe also on, when we do our workshop, that we select data and we exercise it. Because we're very theoretical right now.
Yeah, if I can just, I think Ben's suggestion about running some data through it is a very good one. I mean, we're developing a process that's very theoretical, and I think it would be very useful to run some small number of data points and see which of the 4 categories they end up in, and whether we as a group think that those are the correct categories.
Other ideas or comments on that?
I have one, Sven. Maybe, what do you think about to remove the non-equilibrium from there and to put in the anomalies, put together with the anomaly, this parameter of the non-equilibrium, and leave this only for ranking the technique itself, not the environmental effect of on the technique. Put this non-equilibrium situation because I don't know, because the borehole was just drilled, or because in other circumstances, I don't know, because maybe instruments are removed to introduce the probe, things like that will perturb the well. So maybe this parameter put together with water circulation and other anomalies.
Well, I don't know. I understand you suggest that we just consider the different type of techniques. So let's say logging, tests, bottom hole temperatures.
And yes, but also the sensor itself. Okay, I think this has to be evaluated also.
Yeah, but I could, for example, I could easily imagine that by definition you would rate a continuous profile higher than single point BHTs. But imagine that you have two BHTs that describe your top and bottom of an interval, but that are not perturbed by drilling conditions, and probably gives you a far better absolute value than a perturbed temperature log over that area. So I don't know whether we should exclude the dimension of drilling related perturbations totally from this scoring here.
Not exclude,
Pardon?
not exclude, but include in the anomalies. No, for example, no observation, because it's very difficult to rate the amount of perturbation that the well suffer. So maybe as a comment, say the well was not in equilibrium because of, it's very difficult to put a value to this. No? So maybe an observation, less remark or something like that. Not, or maybe saying, well, was in equilibrium, yes or not.
So you suggest to include this here into the perturbation effects.
Yes, this is my suggestion. But no, only is not a suggestion, is maybe we have to consider this possibility, no? To remove this effect from there and to put it here.
Okay, interesting.
So it's more simple rating the techniques itself,
yeah, without
external effects. That it's very difficult to evaluate, to give a number, a figure.
Are there other opinions on that suggestion?
Because, sorry, I think almost always BHT are measuring non-equilibrium situations, no? Always, because it's like a technical measurement. It's not for heat flow, it's for technical purposes, no?
Yes.
So it's always more or less always it's related, like maybe here the time we can measure, as you said before, no? The time take of the measurement of the can be relevant and can be evaluated, can be rated, but the perturbation itself is not easy to do.
You know, we have just as a counterpoint, we have the perturbation as a information stored in the database, at least after the assessment or reassessment of the database. So perturbation of the top and the bottom temperature value is included. And the depth of the interval is also included. One could also think that there is sufficient literature available focusing on the questions how fast or how quickly is an equilibrium reached with this and that perturbation time and this and that depth. So one could also consider those information to separate between those techniques used most likely in perturbed conditions and those most likely not used in perturbed conditions. So that would be another solution compared to getting totally rid of those discussion of the perturbation here, and just mention it as in the category of perturbation effects. Just to have a counter discussion point on that. I don't know whether it is looking on those assessment projects ongoing. I don't know whether to what extent we can include the information of shut-in times. I think it is sometimes recorded, but often enough probably not. Looking a bit more into future and thinking about that at one certain day we probably have also connected raw data of temperature or connectivity to the heat flow database. Probably opens up a bit more flexibility to take those information into account.
I'll step in here, Sven. It's Rob.
Yes.
In terms of your suggestion, I'm not sure that necessarily adding an extra 4 columns is going to help a hell of a lot. I think that you've got 2 options to improve or increase the opportunity to qualify the data. I would say 2 columns max to be added so that you ended up with 6. I mean, the point in terms of single point temperature measurements, Jeff said that it had 75,000 measurements. All those 75,000 will end up with a quality of 0.5 based on this criteria. So having some sort of measure in terms of whether you have shut-in time of a sufficient period of time that allows you to say it's more accurate than not having a shut-in time, I think is useful. So you could end up adding some sort of detail in terms of the quality of the 75,000 data points that you might have for a single point. But equally, we've spent a lot of time talking about single point temperature measurements. And Ben's made the point, the multiple data is where the critical information is. And I think it's equally important that we look at differentiating or adding some quality indicator to the different multiple point data. Now, whether you go for a range, you could go from 0.5 to 0.6 for your single point, 0.7 to 0.8 for your multiple point. But the issue here is that often it's not until you get to the real data that you realize that, 2 accurate measurements in a well may be much better than a continuous uncorrected for thermal equilibrium measurement. It depends on how recent you've run your continuous profile after drilling. So in fact, you might find that your two well-defined BHTs give you a better indicator of the quality than, say, for instance, a continuous measurement. So there's lots of variation here. We can't cover everything. We've got to just pick our winners and say, okay, this is going to give us a reasonable ability to differentiate between quality measurements, but we can't do everything. So I think 4, maybe 6 columns is more than enough. I wouldn't go to 8. I think it's getting too complicated.
Okay, other comments on that?
Yes, I agree on that. And I think we discussed for thermal conductivity something or somehow similar, because there is, of course, what do we want with this? We want to have some general ranking. And I got the feeling we should take care that we find a robust, simple approach to do this, and that still every researcher or everyone who is going into the details needs to check certain parts. And we could write the discussion we have here down and give some hints on what could affect. So, or what are what could be the pitfalls also in applying our approach of ranking, because we could not develop a ranking which will fit for every single measurement we have in the database, or which will come with all the different quality criteria and something like this. So I think we could be more open to our failures we will do with this ranking. And we need to communicate them and to say, okay, there's specific cases possible or something like this, where we might not correctly address the quality. So I think we should, stay to what is possible and helpful for 80–90% of the data we have. So I think this is, I've got the feeling if we make it too complex, then it will not be helpful anymore.
Just write down, I don't know whether I summarized this correctly. That's what I so it would be 6 categories. Does this reflect, Rob, what you had in mind?
I think that there's no reason why we can't cross over some of these categories. But I wasn't thinking of the 3 single BHTs. A well-corrected BHT is equivalent to your DST probably in terms of a single measurement. So I'd combine those 2. I don't have a lot of experience dealing with the DST data. In most cases, we see multiple DST depths over a very short depth range, usually within the reservoir. And you don't see multiple DSTs within many wells that I've dealt with, but I'm sure that there are others where multiple DSTs are run. And I'll be looking at the same issue in terms of the multiple measurements. So multiple BHT perturbed and multiple DST or BHT corrected. So adding two options for the multiple data point.
Okay, so how should it be mentioned here?
So the number 4, as I've got it, would be perturbed, and the next one would be corrected.
Okay, the next.
So you've got single BHT perturbed.
Yes.
Single DST BHT corrected.
Yes.
Multiple BHT or DST perturbed or inadequate correction, and then multiple BHT DST corrected. I mean, there's an element of symmetry there, but the numbering system may not necessarily reflect the level of increasing quality you get from those. And so what we might find is you change your quality indicator. Here you've got 0.5 for a single point measurement. We might find that you need to change those quality indicators to better reflect the value of the data. But that could be done in future, something which might usefully come out of a practical exercise where you're testing a data set.
Yeah, okay. Generally, I think what Ben mentioned is a quite good idea, that we should use a workshop in June, that we really go through step by step through this proposal so far in small groups with real data at hand, and then exercising the application of the algorithm and with different kind of data and checking for pitfalls, checking for strengths and weaknesses, and then probably adjust those scoring values for each step. And then, yeah, just have a look about the interplay of the several steps and several scores with each other. But yeah, are there comments on this idea of categorization? Remarks? Do you all agree with this subdivision, or should we take this for the first glance and then check and probably readjust during the workshop in Potsdam? So I saw a sum up from Jeff. Massimo.
Okay, so I fully agree there with these 6 categories, but I have a concern about the ranking between the 4th and the 5th level. I mean, that I'm not sure, but this is just my opinion. It's not okay, the truth may be that perturbed logs may be of lower quality in inferring the heat flow than multiple DST or BHT corrected. But this is just my opinion. This is a point of discussion. In my experience, sometimes I found perturbed logs that even though the accuracy of a temperature probe is very high, they are so perturbed that the inferred heat flow is not the true heat flow. I mean, it's a datum of very poor quality. Otherwise, in many cases, I found that very deep boreholes with DST data or corrected BHT data can supply quite good information about the heat flow.
I fully agree with Matthew.
Yeah. I think if everyone is fine with the general categories, that's perfect. And I think the ordering is just then a matter of the score in the back here. So we probably then need to adjust during the Potsdam workshop while having data on hand, right? But yeah, this is then just a matter of negotiations whether we all think that the scoring values of perturbed logs should be lower than of multiple Dristem tests. But I generally I can follow the idea you mentioned here.
Only precision about that. Yeah, I agree. I like this ranking, but only to point out that logs perturbed here is different from groundwater circulation anomalies. Okay, in my head, this, for example, is the case where I want to go to measure a well, and this well is, for example, is provided with a pump with a instrumentation for, I don't know, water extraction or pumping, and I ask to remove the pump maybe only 1 or 2 days before. For sure, the well will not be in full equilibrium, and this is the perturbation that I will expect to find there. No, it's only if it's this perturbation that we are referring to. This kind of perturbation, not the environmental ones.
So is this fine at the drilling perturbed, right?
But not only drilling. Maybe imagine if it's for water extraction. The well is drilled a long time ago, but now it's equipped with for a pumping instrumentation, and I ask to remove the pumping for measuring the point, maybe. And this happened in farming areas, and a request to extract the pump for measuring 1 or 2 or 1 week before or 2 days before my measurement. So for sure, the circulation of water will perturb the column. And maybe it's a very old well, but it's perturbed for the activity that they are. You see my point? Is this kind of perturbation that I expect? So drilling, activity in the well.
Can we subsummarize this with installation?
No, I'm not asking you to specify this. Only is to see the difference between groundwater circulation for environmental for the environmental situation about around the well, and another one is for technical. This perturbation has to be due to technical activities in the well. drilling, instrumentation, or imagine that the probe, the thermal temperature is not the first probe to introduce. Imagine that I don't know, another experiment has been done before. Things like that.
Okay. Okay. Okay, I've noticed this point.
Just a question. What about those step-by-step measurements? They are not in this table now.
What kind of step-by-step?
I mean, step-by-step, every 5 meters, every 10 meters, by using, let's say, platinum 100, platinum 1000 probe.
Yeah, this is summarized under logs in this terms. So that
Logs, okay.
thermistor that used with a winch, right? Or optical fiber T measurements.
So it is put under logs. All right. Yeah.
My general impression is that that most of you are fine with those 6 categories, and probably with the general ranking of the categories as well. But there are 2 hands. Okay, that was too quick. Sandra, I think you raised your hand first, and Ignacio.
Off you go. I may have done that by mistake.
Ignacio?
I'm happy
So
with those. Looks good at first.
I agree, it's good. So only in point 4, maybe it's because I confuse everything. Drilling is not necessary anymore. So logs perturb. No, drilling is not necessary anymore.
Oh.
And even for the others, I didn't want to this to be. It's only to put in clear that these perturbations are specific to the activity in the well, in the well. So drilling, installation, and other activities, to differentiate from the other ones, from the anomalies or perturbation for one or the circulation or others.
Okay. Yes. Okay. If there are no objections, I would use it as a great result of our discussion for today. And this then would be fill or replace those first rough 4 columns here. And I think that since this was a piece of work, I'm not sure whether we should start into those questions of representativeness and the questions of variability and homogeneity. I don't know. This is those parts here. So the questions how many measurements are required in terms of the inhomogeneity of the interval we are looking for when it comes to heat flow. This is actually the big frog we need to solve, and we circulated around during the past 3 workshops. We technically would have 20 minutes for discussions, but we could also close now if not someone wants to propose an idea for that straightforward. Well, because if this is not the case, my suggestion would to close now and to take those results we already have now and probably it could make sense to take those open questions, how we want to consider the number of measurements in terms of the variability of information or the inhomogeneity, as a kind of homework. It could also could be an option that if someone has an idea, we can freely propose this by email into the round of interested people. Honestly, I'm not sure whether it makes sense or whether we will have another workshop on this before the meeting in June. The reason for that is simply that from the Potsdam side, Ben and me, we will be covered with loads of work to organize the CHRMAC meeting in June. And we have some other workshops before in May, so there is not plenty of time. And beside that, there should be a first workshop on the marine aspects as well, probably next week or the week after. And so this is also something to do. And this time, I think this now could be a nice results for the quality aspects here, and probably we need to develop some approach for the questions of the representativeness, which we should then discuss in Potsdam. Probably this is, or in the meantime by email or so, but not in a particular next workshop online. This more or less out of the cold would be my suggestion now. What do you think, folks?
I second.
Very good, excellent. Okay, no objections. So with this, I think we have a nice solution for the temperature-related aspects found here. Thanks for your contribution. Ben and me, we will write the minutes for the past 90 minutes we had here. We will circulate as usually this within 1 week to you for your comments. And then I really would like to encourage you to think about how we could relate the number of measurements for conductivity or temperature in relation to the variability of information, because this is something we discussed during this workshop, the last one and the one before, as something we need somehow to cover and reflect, and we have no convincing solution so far for that. Ben and me, we will circulate an agenda for the in-presence workshop in June for the CHRMAC meeting as well, probably in 4 weeks or so, that you can prepare for that if you attend. And yeah, with that, thank you very much for all the contributions. A nice discussion to see every one of you here. And thanks for being up early or late, depends. And yeah, goodbye for today, I would say.
Bye-bye.
Yeah, goodbye.
Thanks, everyone. Bye.
No picture today.
Bye-bye.
Bye. Thanks, Phil.
Bye-bye.
Bye.
Bye.
Ciao, Paolo.
Ciao a tutti.